So in our previous sessions, we have started with our packed arrays and we have seen 1D packed array and 2D packed array we have seen. And also we have seen our 3D packed array, how it is going to look like. This and all we have seen in our previous sessions, right? Now, in this particular session, we are going to start our discussion about unpacked arrays. Now, let us see, first of all, what do you mean by an unpacked array? Okay. So in the case of my unpacked array, I am going to have again the classifications 1D packed array, 2D packed array, and 3D unpacked array. Okay, so I'm going to have 1D unpacked array, 2D unpacked array, and 3D unpacked array. Okay, so first let us start our discussion about the first type of unpacked array, which is 1D. Okay, now let us see the syntax first. So coming to the syntax of this 1D unpacked array, so this is how it is going to look like: data type followed by variable name and followed by the size. Okay, so here in the size you can mention LSB to MSB. This is basically the number of locations you are going to mention. Here it is number of locations. For example, you can simply write down reg ARR 0 to 7. That means you are going to basically have 8 number of locations. So how it is going to look like? So let me show you. So in the case of your unpacked array, you are going to have different memory locations. So like this, you are going to have 8 different locations. So this is location 1 with index 0, location 2 with index 1, 2, so on up to 8 number of locations, and the last location is 7. And in the case of packed arrays, if you carefully observe, if I am going to write down reg 7 down to 0 or 0 to 7 ARR, you are going to have an array which is going to have 8 number of locations in a continuous fashion. Okay, this is a contiguous memory locations, everything is packed. But here in the case of your unpacked array, you are going to have 8 different separate locations. Okay, so this is the difference between your packed array and unpacked array. Okay, now let's say you can also simply write it down as reg ARR of 8. That means you're going to have 8 different locations with 0 as your lower index and 7 as your upper index. Okay. So this is how you can declare a simple 1D packed array. Is it clear for everyone? Any doubts or any queries in this? Shall we move forward? Is it clear? Yeah. Now, let's say if I'm going to have a code like this, let me show you. Let's say if I'm going to declare a array rich A of 3, that means I'm going to have three memory locations. Now within an initial begin and block, if I'm going to write down simply initial begin A is equal to 3 tick binary 101 end. Now is this code correct or wrong? Can anyone tell me? Is it correct or wrong? What do you think? If I'm declaring a array with 3 number of locations and if I'm going to assign A is equal to 3 tick binary 101, is it correct or wrong? You can represent LSB to MSB or else you can represent the number of locations you want. Both are acceptable. Or rich ARR of 0 to 7. This is also acceptable and this is also acceptable. Okay. Now coming to my question. Is it correct or wrong? Okay, I got one answer only. What about remaining people? So the piece of code which I have written, is it correct or wrong? Yes or no? Okay, let us see here. Let us see in our EDA playground. Let me declare it. Rich ARR of 3. Initial begin ARR is equal to 3 tick binary 101. Okay, and let me end it and end module. So incompatible type at assignment. You are going to get incompatibility. So what is basically happening is, if you are going to declare a array, you cannot directly assign the values to that particular array. This is not allowed. Okay. If you are declaring an unpacked array, you are not allowed to directly assign the values to that unpacked array. But if you are declaring a packed array, you can declare the values or you can assign the values directly to that particular unpacked array. Yesterday we have seen. But if we are declaring an unpacked array, you cannot directly assign the values to that unpacked array. Okay. Now, how to assign the values, sir, is so basically for assigning the values to unpacked array, we have different methods. Okay. So the very first method which we are going to use is using index. Okay. So using the index of your unpacked array, you are going to assign the values. Okay. Or else you can use for loop, and we can also use for each loop. Okay. So these are the ways which we can use for assigning the values of an unpacked array. One is using the index and another is for loop and another is for each loop. Let us discuss what do you mean by for each loop and all we will discuss. Okay. So this is how you can use, and we have one more method also. The fourth method is array aggregate method. So these are the methods which we can use for assigning the values to our unpacked array. Okay. Now let us see the very first method using our index. Okay. So using the index, we need to assign the values to our unpacked array. How to assign? Let's say if I'm going to have an unpacked array rich ARR of 3. Okay. So within an initial begin block, I'm going to simply write down initial begin ARR of 0 is equal to 1 and ARR of 1 is equal to 2, and sorry, it's a single ridge, right? Okay, so before that, before that, can anyone tell me if I'm going to have, this is by index. Okay, I have one question over here. So if I'm going to declare ridge ARR of 3, how many locations will be created here? Ridge ARR of 3, how many locations will be created over here? 3 locations. Okay, so 3 number of locations are created. This is location number 1 with index 0, 1, 2. Now, what will be the width of each location? Like each location can contain how many number of bits? Can anyone tell me? What is the width of each location? Each location can contain how many number of bits? Only one bit. Exactly. This is a very important observation over here. So if I'm going to declare it as reg ARR of 3, then your each location can contain only one bit because we are using a reg over here. Let's say suppose if I'm going to use reg, or let's say if I'm going to use int ARR of 3, then each location can contain 32 bits of data. Okay, so this is a difference. Okay, now let's say if I'm going to use rich ARR of 3, then here I can contain only one bit of data. Is it clear for everyone? No, no, no. Default value of reg is unknown. That is correct only. I'm talking about the size. Okay, each location can have one bit of data. That is what I'm talking about. Okay, yes. Now let us come here. Let's say if I'm going to write down ARR of 0 is equal to, I can have only one bit of data which can be stored in each location like this. And ARR of 1 is equal to 1 tick binary 0, and ARR of 2 is equal to 1 tick binary 1. Okay. So what is that? I can store 3 bits of data like this. Or else this is one method of using indexes. Using index method, I can store the data like this. Okay. Now let's say if I want to display it, $display the value of ARR is percentage. So for displaying also, I have different ways. 1 minute. Yes, yes. Now, so what is that I'm going to have? Let us see. Let me display it using the percentage %p operator. So if I'm going to use percentage %p, comma, ARR. Okay. So let me display it. So what is that I'm going to get? The value of ARR is 101. Is it clear? So I can use a simple percentage %p operator for displaying my things. Okay. Is it clear for everyone? Any doubts or any queries in this? Great, great. Now, I can also use a for loop for displaying my array contents. Okay. So how can I use my for loop for displaying my array contents is, so let's say if I've declared a simple array like this, int ARR of 3. Okay. So I've declared int ARR of 3 if I've declared simply. So for displaying it, what I can use is, I can use for I is equal to 0, I less than the size of this array. Okay. So what is the size of the array is 3. Okay. So I less than the size of the array and I plus plus. Okay. So I can use dollar display a of I is percentage %d, comma, a of I. Okay. So like this, I can display this particular array. Okay. So let me display it. Yeah, percentage %0p is also possible. You can use it. Okay. Is it clear? Okay. Sorry, here percentage %d or percentage %b if you want to have it. Okay. Let us see here. Let us use a for loop for using it. So how to display it? So using simply for loop for I is equal to 0, I less than the size of the array is 3 and I plus plus. Okay. So what I can do, dollar display, the size of the array is percentage, sorry, not the size. The value of array is a of, sorry, what is your array? ARR of percentage d. Okay. ARR of percentage d is equal to percentage d. I am going to display the index as well as the value. Okay. And it is ARR of I. So, comma I. Sorry, I will display first the index and my array value, ARR of I. Okay. So what is going to happen over here is your for loop is going to iterate for each and every value. For I is equal to 0, it is going to have the I value, that is I value will be equal to 0. For index 0, what is your index value? It is going to print. And what is the value it is going to have? It is going to print. Okay. So let me end this and let me display it. What happened over here? Okay, we haven't declared the I over here. Let me declare it. Let me declare it as int I. So we are getting ARR of 0 is 1, ARR of 1 is 0, and ARR of 2 is equal to 1. Is it clear? Yeah, exactly. Okay. So is it clear for everyone? Great. Great. 1 minute. Give me 1 minute. Yes. Now, let us see the next method, which is array aggregate method. Okay. So coming to my array aggregate method, how to use my array aggregate method is, let me show you. So that was the first method where we are using the index for storing the data inside your array. Okay. So next is for loop. We will come back to for loop and for each loop. First we will see this array aggregate method. So if I am going to have a array like this, int arr of 3. Okay. And if I'm going to use array aggregate method, so initial begin, what I'm going to simply write down is arr is equal to, I can have the values 1 tick binary 1, comma 1 tick binary 0, comma 1 tick binary 1. So I can have the values like this. Okay. So this is nothing but my array aggregate method. Okay. Let us use this method. So let's say if I'm going to have simply, let me comment this. ARR is equal to tick 1 tick binary 1, 1 tick binary 0, 1 tick binary 1. Okay. Let me display it. Okay. So what is it? I'm storing this particular values. Okay, using this array aggregate method. Or else you can use indexing method. Okay. So is it clear for everyone? Both the methods are they clear? Yeah. This is the syntax for your array aggregate method. Tick followed by curly braces. Okay. So basically what you're going to do is in your array aggregate method, you're basically packing all the bits and you're going to store according to the indexes you're storing into the array. Okay. And when you are using percentage p operator also, this percentage p operator is basically packing all your bits and it is displaying them. Okay. So instead of you writing for loop and iterating through all the locations, this percentage p is going to convert them into packed format and it is going to display them. Okay now? Yes. Now coming to my for loop. So using my for loop, what I can simply do is I can simply use this for loop for initializing of my arrays. Generally in my codings, if I want to initialize my memory elements, then or my memory locations, what I'm going to do is I'm going to use my for loop. So for I is equal to 0, I less than, I can use one function which is known as dollar size of ARR. So basically it is going to return the size of my array. Okay. And followed by I plus plus. And what I can simply write is ARR of I is equal to 0. Okay. So like this also I can initialize my array. Let me display it. Or I can store the values inside my array. Okay. Let us see what we are going to get. So let me comment this line. So I'm going to get zeros filled in all the locations. Okay. And if you carefully observe, if I'm going to use this for loop, then this for loop is going to we need to write down the initialization, that is I value, we need to make it to 0, and again we need to have the boundary, that is I less than dollar size, and we also need to write whether the incrementing or decrementing, I plus plus or I minus. Okay. But if we are going to use a for each loop, if we are going to use a for each loop, this is going to initialize the variable, and before that we know we don't need to declare the variable also. Okay, no need for declaring the variable also. Declaring I. So here if I want to use I in my for loop, I need to declare it. But if you are using a for each loop, then no need of declaring I also, or whatever the variable you are going to have. Okay, and it is going to initialize and it is going to iterate. Okay, and it is going to iterate below the size, below the size of the array, or up to the size of the array. Okay, so it is going to iterate up to the size of the array. So this is what your for each loop is going to do. Okay, how it is going to do, let us see. Okay, So for example, if I'm going to have a simple for each loop, so yeah, exactly. For each ARR of I, you are correct. Okay. So what I can simply do is I can have for each of A of, let's take J. Okay. ARR of J. ARR of J is equal to 0. Okay. So what is happening? It is iterating, it is going to declare the variable J and it is going to initialize it and it is going to iterate that particular value of J less than the size of that particular array. Okay. So you just simply write for each of ARR of J. That's it. Okay. So see, again it is happening and it is initializing to zeros. Okay. Is it clear for everyone? Yes or no? Any doubts or any queries in this? Great. Great. Yes, it directly initializes from zero. Exactly. Okay. Now let's say if I want to print the array, I have for loop for printing the array, or I can have percentage %p for printing the array, or else I can use for each loop for printing my array. Okay. How to use it? For each of A of ARR of G, ARR of G, I can print it directly, dollar $display. The value of array is percentage %d, comma, ARR of G. Okay. Let me display it. See, it is directly printing it. Okay. The value of array is 0. I'm not printing the indexes. I'm just printing the values. That's it. Okay. Yes. So is it clear? The three ways, are they clear? One is using the for loop and another is percentage %p and another is for each loop. So this is how you're going to have an unpacked array and you're going to print it. Yes. So any doubts or any queries in this particular things? Okay. Okay. That's great. So in our next session, we are going to start with